we have seen what is support and its reactions. So this is basically three types of supports: a roller, hinged and fixed. And we have seen some example problems. So when you work out 2-3 problems in your book, obviously you will find out the difference of that, and the basics is same. So do not forget, you will have to find out sigma H, sigma V and your sigma M, which are the basic 3 equilibrium reactions. Equilibrium equations of equilibrium it is, right? And the difference between roller support, hinge support and fixed support you should know, right? That's one point. In the next continuation, you have to see types of loads. The supports is from the opposite side. A load is been acting and support will be in the opposite side. It's a reaction, right? Now types of loads, you have some 2 or 3 categories that we have to study it and find out solve 1 or 2 problems in that will be easier for you. When you see the loads, basically there are types of loads. Okay, in this first one we will take a point load. Okay, and something called uniformly distributed load. Distributed load. There is something called, short form is UDL, uniformly distributed load. And third one something called uniformly varying load. Varying load. That's called UVL. There are 3 kinds of loads in basics. So this point load, or otherwise called concentrated load. Concentrated load. Is nothing with this is, but this is load. Say suppose you take a beam, right? Beam with some supports. Okay, so this is an hinge support. This will have a roller, whatever it is. Okay, with the no, we have to remember that with the shape we have to identify what type of support it is. It is the roller here and hinge support. If I have a point load, say suppose is 10 kilonewton, and if my total length of the beam is 5 meters. Okay, this is a point load. Just we have to know that it is acting at point A. Suppose this point A, this point B and point C. This is acting in single point only, that's why it's called point load, or also it's called concentrated load. Fine. So this is directly we can take, and if it is a vertical load, you can directly, since it's acting down, you can find out a value of sigma H or sigma V. Horizontal is not required here, it becomes 0. Vertical alone we need it. Sigma V means acting down, it's minus 10 kilonewton. We'll find out the value for the reactions. You can obviously find out because roller will have VA, this is VB here, hinge is roller, and you will have here VA and HA, horizontal loads. That's it. So this becomes your point load. And the second one, what you are going to see is uniformly distributed load, UDL. This meaning of this is whatever the load is applied to the beam, it is considered to be uniformly distributed, which means I'll take a beam like this. I have a hinge support and I have a roller. Okay, now I have, this is VA and HA. This is your basic reactions you have to write. This is VB. Now this, suppose the same 10 kilonewton is acting. If I want to show this in terms of your uniformly distributed load, I can draw a sketch separately and show. Okay, 2 reactions here. I'll just show in this fashion. This indication, this marking, this fashion shows this is a uniformly distributed load. How to write this is, the 10 kilonewton at a span of 5 meter is the beam length. Okay, it's 5 meter. I will write it as, this 5 meter is this. Okay, I will write it as, just show an arrow mark like this. And so this 10 kilonewton, 10 by 5, it is 2.5. Sorry, it is 10. At the center of this 5 meter, you should have this 2.5 at the center load, center point. This 10 by 5, this is 2 kilonewton is your load. This 2 kilonewton per meter is the value. What I mean to say, 10 kilonewton is the point load here, acting at center point of this beam, which is a total length of 5 meter. This can be shown in terms of uniformly distributed load, that is UDL, in this fashion by indicating here 2 kilonewton meter per meter. You understand? That means at the center point of this beam, at 2 kilonewton per meter is acting, which means how we arrive at this 2 kilonewton meter? We consider to be the 10 kilonewton is acting at center point of this beam, where it is 5 meter. So it is 2 kilonewton per meter. That is 10 divided by 10 is the total applied load divided by this 5 meter. 10 by 5 becomes 2 kilonewton. So 2 kilonewton per meter is the load acting when it is taken as uniformly distributed load. This is the rules. Point load means a single point acting at any direction it is. Uniformly distributed load will be always shown in this fashion with this kind of arrangement indications, and indicated with the value of 2 kilonewton per meter. Uniformly distributed load will be given in terms of kilonewton per meter it is. It cannot be given in terms of kilonewton directly. It is not a force, it is force with a value of its distance also, right? So this is number 2. And number 3, the third one is your uniformly distributed, varying load. The third one, UVL, it's called uniformly varying load. Here the variation can be shown at any directions. For example, I just show a beam with a value, okay. Here I have a point load here, say 10 kilonewton, okay, and I'll show one triangle, a load with different shapes, which means the load of 2 kilonewton is acting here, okay. The variation can be shown in all the every point. The varying load means the load will be minimum at one point and maximum at the other point. So instead of writing this beam, I can write it separately. For example, you consider this triangle, okay. Shape of this is a triangle. At every direction I have some load, right, and this I consider as a beam. This is my beam, this beam. So this is a varying load at point A and this point B. How can I write it? The load at point A is 0 kilonewton. Why? Because there is no load here. Suppose this my total length is 2 kilonewton. In terms of kilonewton can be indicated. At load at point B is equal to 2 kilonewton. This is how I will write, because this is uniformly varying load. At every point the load keeps on varying. Its value may be either increasing or say it's decreasing from other end. Okay. So there are 3 types of loads which have been studied. One is point load or concentrated load. Second one is uniformly distributed load, wherein you are just converting the applied force in terms of the total distance given and considering to be it's acting at the center point. And third one, uniformly varying load, wherein at one point of the total beam it will be a very minimum value, say 0, another point will be the maximum value. It's uniformly varying load. So with these 3, if you solve, to find out, analyze one problem, you will get more idea about this particular topic. The third load in that, so first one is your point load, next is uniformly varying load, uniformly distributed load. So uniformly varying load, just before going to the problem, we will see this sketch, okay. For example, this is a sketch. So wherein, just consider this as a brick construction. For example, this is my beam, right? On top of the beam you have a construction like this, made up of bricks. So this shape is a triangle, and this I call it as masonry work, masonry work. Okay, so the load or the total weight of this particular, for this beam, we have to just convert it into different shapes. That is, based on this shape, what is the shape? This is a triangle. I would say at point A and point B, two different points. At point A my load will be 0. Load at point A equal to 0, and load at point B will be maximum. Okay, so this is the idea. So in this, load at point A is 0 and point B is maximum, but you have something called center of gravity, which means depending on the area of this shape of this body, for example a triangle, we will have to find out at what exact point the total load of this acts, which what I mean to say, the center of gravity should be found out, and we have to decide in particular center of gravity only the total weight of this body will be acting. But before that, what is the area of a triangle? Just it's a half into B into H, breadth into height. So if I just take, this is my length of L beam and this is my breadth, some value, so half into breadth into height will be my load point or my center of gravity, or I will write it as CG. Okay, center of gravity is denoted by CG shortly. So the center of gravity will be found out, and then we have to decide at what distance the particular load is acting. But before we are going for the load calculation, the center of gravity of the body should be found out, because at center of gravity point only the total weight of this particular body will be acting, right? So that is the difference in finding out. The point load is directly given, uniformly varying load is varying from one point to other point, where you just multiply the applied value into distance, and third one is uniformly varying load, right? So when we solve one problem on this, it will be easier for you to understand. That we'll see, right? So this is one kind of problem here. It shows calculate the support reactions of simply supported beam. Okay, here it is given as an uniformly distributed load UDL. So this shape denotes UDL, and one more uniformly varying load UVL. Now before solving this problem, first we have to convert this sketch into a normal sketch with the just indication of loads alone. It will be easier for you to calculate your sigma h, horizontal, vertical and moment, the equations of equilibrium, right? So first we will convert this UDL into normal load. How do you convert? First step, you convert this UDL. Okay, what will you do? The given sketch is like this. Span is 4 meter, given as 4 meter length. Okay, and it is given as 1 kilonewton per meter is the question given. Now how do you convert this? This 1 kilonewton is, it is supposed to be acting at center. 1 kilonewton is the force. Total length is 4 meter, and since it is acting at the center, it is at 2 meters. That is the meaning. Now how do we write it? We are finding as 1 kilonewton into 4, 1 into 4, 1 kilonewton into 4 meter into 4 by 2. The load is acting at center point of the total span. Total span is the total span of this UDL alone, uniformly distributed load alone, is this much. Okay, this is the idea. So this is your conversion, first step. And second step, you are converting this uniformly varying load, a triangle shape here. And see the indication of this load height, this point is, say suppose 0, is coming 0, the maximum height is given as 2 kilonewton is the load. Okay, which I will draw it here and see. It is given like this. Okay, this point B, the total distance is given as 8 meters here, 8 meter span, and this height given as 2 kilonewton. This is the maximum load. It is uniformly varying load. It varying from 0 Newton to 2 kilonewton, right? Now this has to be converted into again normal load. How do you convert this here? First we have to find out, same condition, we will find out the center of gravity. Center of gravity means, I already told you, this is the shape of a triangle. For this we know the area. So for this triangle, the area is half into B into H. Okay. Now, so this shape is the triangle and the area is this much. So if you cancel this 2, it will become 8 meters. This is the load value. 8 kilonewton it is. Is the load value. Now, the load is acting at centroid, center of gravity. That is confirmed now. At which point it is acting is a question. Which point means from the either from the bigger end or the smaller end. At which point it is acting is a question. Now, how to find out this one? In this triangle, there are two options. Either from the bigger end or the smaller end, the load is acting. Load is 8 kilonewton. It is confirmed because of the area is half into B into H. At which place it is acting? If you calculate from the bigger end of the triangle, you should travel in this direction, which it is 1 by 3 into length. You understand? After calculating the area, there is half into B into H, which gives the total 8 kilonewton, because B is 8 and 2 is the H height. You calculated, get 8 kilonewton. Now at that 8 kilonewton is the load of this triangle load, but where it is acting, we have to find out. There are 2 points. Either you find out from the bigger end where it is acting, because this triangle can be modified written like this. You can have a triangle like this, is it not? So you can calculate from this lower end, smaller end or bigger end. The rules is, if you start from the bigger end, you calculate the distance is 1 by 3 of the total length. That is 1 by 3 into 8 here. I say this is 8, 1 by 3 into 8. Suppose you start from the smaller end, you write 2 by 3 into 8. L. That's it. Very simple. So first point, you have to write this area. It's a triangle, rectangle, whatever it is. Triangle, you write the area, it shows the load. Second point, the load applied, acting at which point, at what distance. That is, if you calculate from the bigger end of this triangle, you write it as 1 by 3 into L. Okay. If you calculate from the smaller end of the triangle, if you write it as 2 by 3 into L. Is clear? And on this problem, we have to calculate from smaller end or bigger end, wherever it is. But our purpose is to find out sigma H horizontal, sigma V and sigma M moment. Horizontal and vertical based on only the applied loads. We will find out values of either VA, HA or VB, HP, whatever it is. This is a hinge here, VA, HA, and roller we have VB. But when you go for moment only, we need to record, we have to write out these values, at what point it acts. That we will see it now. Fine. So I'll just write moment here. Not only the moment, all your three, sigma V, sigma H and sigma H, sigma V and moment. Now we will find out sigma H here. What will be here? Horizontal, you have HA minus HA. Anything else? Horizontal load here? Nothing is there. So equal to 0. Fine. Then you go for sigma V. What do you have? VA is up. You have VA. VB again plus VB. And what else you have? You have converted this 1 kilonewton into point load. Remember, it is acting down. It is minus of 1 kilonewton into 1 into 4 I said. Is it not? 1 into 4 is a load, that is weight, into, sorry, I want just weight is 1 into 4. That's just 1 Newton. 1 Newton into total span 4. Minus of 1 into 4. Again, in this UDL, uniformly, UVL, uniformly varying load, you have again minus, the total length is half into, total load is half into B is breadth, is B into H, H is height, it's 2, this 2. Clear? We have converted this sketch into previous sketches what I have written previously. Here I am showing the vertical load alone. VA is acting up positive, VB is acting up positive, minus this 1 kilonewton into span of 4 meters, the total load, 1 into 4 it is. It is 1 into 4 acting. And again, the half into B into H is this total load, right? So you will get a value of VA plus VB, some x newtons, kilonewton. Then you go for moment. This is procedure is same. Go for moment about point A. Now here comes, here in the moment you have to indicate the perpendicular distance. Moment is force into perpendicular distance. Here again what to write? For the moment HA, you don't have anything, 0. VA here, VA into again 0, I take at the same point. And what else you have? You have the next value of this 1. Here it is moment acting down, it's positive. 1 into 4 into 4 by 2. 4 by 2 is the total distance, center point. And this is again plus a load acting down, half into B into H, again into that, what is the distance acting it is? Here it is 4 by 2 is the center distance. And the load is 1 into 4 for this uniformly distributed load, into 4 by 2 is the distance. Force into perpendicular distance is 2 meters. 4 by 2. This 4 by 2. Clear? And again it's plus is because acting down and clockwise moment. Off into B into H is the load again, the same thing. But what is into distance here? Distance is, if you are calculating from bigger end of the triangle, you should write it as 1 by 3 into L. Or smaller end of the triangle, it is 1 by, bigger end of the triangle, it is 1 by 3 into L. Smaller end of the triangle, 2 by 3 into L. We need to neglect this portion only, because moment is about point A. Force is acting here to clockwise. Right? So we have to neglect this portion and remaining you have to calculate. Then how to write? I will write it. We have to neglect that value of, say take 1 by 3 into 1 by 3 into this length, that is 8 meter. Fine. So this 1 by 3 into 8 meter is some value which you have to reduce from 12. What is this 1 by 3 into 8? Say suppose 5 point something. So 12 minus 5.3 something, some value is the distance. What I will write here, 1 by 3 into 8 is the center point of the center acting. So I will write, this is the load, half into B into H is the load, into 12 minus 5, 5.3. This 5.3 comes from 1 by 3 into 8. 12 is total length. This 12 into 5.3, somewhere here. This gets neglected and this is the moment. So this you calculate, you get some value. So you get a value of VA plus VB here, and one will be known from this. Say suppose VB, again VB here, VB into 12. This plus again is minus anti-clockwise, VB into 12 Newton. So unknown will be VB and you get a value of VB here. That's it. Is clear? So sigma H, sigma V and M, sigma M. The procedure is same, only thing is based on this shape or type of the load, you will have to write the where the centroid point or the acting load is acting. So first thing is you have to convert this normal given UDL or UVL into particular single point loads. Then you should calculate the area. Area means based on the sketches which shows the load, then at what point it is acting. So kindly remember, for rectangle, triangle means it is from the bigger end. If you calculate the center point, centroid point, it is 1 by 3 into L. And the smaller end it is 2 by 3 into the total length, L length of this triangle. That's it. Okay.